Okay, today we're going to divide radicals. So yesterday we did multiplication, we've done addition and subtraction, and now we're going to do division. So if a fraction is under a radical, so this whole fraction is under a radical, we're going to split the top and the bottom into their own radical. So now I can split this and say, okay, well, A can also be under a radical, and separately B can be under a radical. So either way, whether you have it under one full radical or you can separate them, just know that these are equivalent. Okay, so when we do division, we always want to make sure we rationalize the denominator. And what that means is that you cannot leave a radical on the bottom of a fraction. So when you look at something like number 1 and you see, oh, there's a radical there, you should never have a radical in your answer. So the way we fix that is we multiply the top and the bottom by the bottom radical. Okay, so some of them you want to try to simplify first. In fact, I would even make yourself a note that says simplify first if you can. So like on number 1, I can't simplify the 2 and the 3, but I can simplify the 16 and the 4. So if I reduce that a little bit, I get, well, actually, let's just take the square root of those. Square root of 16 is 4, and the square root of 4 is 2, so that becomes 8 over 6, which reduces to 4 over 3. So that one, we didn't even have to do anything with our radicals. These were both perfect squares, so we went ahead and just simplified them. Okay, number 2. So here on number 2, this is like what we did up here with the square root of a over b. So I'm going to split that first. I'm going to do square root of 8 on top and square root of 3 on the bottom. So we want to eliminate this radical from the bottom, and the way we do that is we multiply the top and the bottom by that same radical. And the reason we do that is because when you multiply a radical times itself, so up here, let's write this. Square root of a times square root of a is just a. The radical basically eliminates itself. So up here, we would get on top square root of 24 over 3. So let's simplify that 24. 2 times 12, 3 times 6, 2 times 3. Oh, something's not right there. Let's try again. 2 times 6. There we go. So square root of 24 is 2 times the square root of 6 over 3. And that is your final answer. Okay, so let me say that again. We split the 8 and the 3 up, and then we multiply the top and the bottom by square root of 3, multiply across the top, multiply across the bottom, and this eliminates. So what happens here is square root of 3 times square root of 3 is square root of 9, which is just 3. So that's where that's coming from. Okay, let's try another one. Number 3. So first thing, let's split that radical. Okay, and now we can multiply by the radical, or on this one, we know that the square root of 4 is just 2. So we can just leave it like that. Okay, number 4, we have a square root of 10 on the bottom. I cannot simplify this 5 and 10. This one's outside the radical and this one's inside the radical. So we're going to multiply square root of 10 on the top and the bottom. So this would give me 5 square root 10 over 10. Okay, remember when I multiply this square root 10 times square root 10, I get just 10. Now I can simplify these two because they're outside the radical. So that would simplify to 1/2. And we just have that square root of 10. And what you would most likely see is square root of 10 over 2. We don't usually write that 1 there. Okay, number 5. So again, let's multiply. There's nothing I can simplify first. So let's multiply the top and the bottom by the square root of 3. So we did multiplication yesterday, so we're going to do the 2 first outside because it can't be multiplied with anything else. And then 2 times 3 is 6 over 3 on the bottom. I can't simplify anything, so this is my final answer. Okay, number 6. Before I split it, I noticed that I can divide both of these by 2. So I'm going to go ahead and do that. If I reduce that, I get square root of 4 over square root of 9. Okay, so I just divided each one by 2. I reduced this fraction. Well, now what do you know? Square root of 4 is 2 and square root of 9 is 3. So I just saved us some trouble of trying to multiply the top and the bottom by square root of 18. So we get just 2/3. Number 7. Now number 7 is a little bit different here. Let's go ahead and first split this apart. So we have cube root of 2 on top and cube root of 3 on bottom. So if I flip back over for a second, the reason that these cancel, like square root of 3, sorry, right here, square root of 3 times square root of 3 is just 3, because when I multiply these together, I get a perfect square, which then the radical can go away. Same thing here, square root of 10 times square root of 10 is square root of 100, which is just 10. Okay, so one of the ways to do a cube root is, in order for it to go away on the bottom, instead of multiplying the top and the bottom by a cube root of 3, because that won't eliminate our radical, let's think of something that our 3 can go into that's a perfect cubed. So our perfect cubes would be 2 cubed is 8, 3 cubed is 27. So we know 3 can't go into 8, but I could get 3 to be a 27 by multiplying by a 9. Okay, so I'm multiplying this 3 by a number that would give me a perfect cube. So if I multiply that across, I'll come down here. On the top, I get cube root of 18 over cube root of 27, and we just said the cube root of 27 is just 3. And on the top, we'll just leave cube root of 18. Okay, now there's another way to do that, so I'm going to show both ways. This is one way where you multiply something to get a perfect cube. On number 8, let's try the other way. So I'm first going to split it into cube root of 5 over cube root of 4. Okay, so on the square root, we multiplied 2 things together. So if I had a square root of 3, I multiplied it by a square root of 3 to get just a 3. Okay, and the reason I do that is because 2, since there's that little 2 here, I need 2 of those to cancel. So if I have a 3, I could multiply by a total of 3 of those, and they will go away. So if I multiply 3 cube roots, they will eliminate themselves. Okay, so that's the other way, but let's go ahead and I'm going to complete this one like we did the first one, because I think it's a little bit easier. It's a little bit shorter, that's for sure. Okay, so on the bottom I have a 4, and I'm looking to see, well, what perfect cube can I get to? Well, I can get to 8 by multiplying by a 2. So you see, that's much easier than multiplying by those 2 4s. So if I multiply across here, we get cube root of 10 over cube root of 8. And the cube root of 8 is just 2. So this is our final answer. Okay, number 9. Let's reduce first. It's going to make it easier. 6 over 54 reduces to 1 over 9, or 1/9. Okay, so I'm just reducing this fraction to be 1 over 9. Okay, on the top, cube root of 1 or square root of 1 or anything of 1 is just going to be 1. So let's go ahead and rewrite that as a 1. Okay, so now I have a 9 here, and I want to try to get it to be a perfect cube. Well, we know that 9 goes into 27 if I multiply by a 3. So if I multiply across the top, I just get cube root of 3. On the bottom, I get cube root of 27, which is just 3. So my answer is the cube root of 3 over 3. There's a lot of 3's there. Okay, number 10. Again, we can't simplify anything. Well, let's just go ahead and multiply. So I have a radical on the bottom. In order to get rid of it, I multiply the top and the bottom by a square root of 2. Now be careful here, because I have 2 things this is multiplying to, so I'm going to distribute. So we would get 4 square root 20 minus square root of 180 over 2. So we need to simplify the 20 and the 180. So if I simplify the 20 first, that would change into 8 times the square root of 5. And then we'll simplify the 180. Which I can do 9 and 20. So that will become negative 6 square root 5 over 2. Now, on the top, we did adding and subtracting. I ended up with the same radical here, so we can combine those. 8 minus 6 is 2. And these reduce to just a 1. Now, I know that's a lot in that problem, so you may want to pause it, rewind it, and rewatch that problem again. Okay, so then these last two. On the bottom now, we have a binomial here. We have 4 plus the square root of 2. So on all the other square roots, we could just multiply by a square root to get rid of it. But here, we're going to multiply by what we call the conjugate. So a conjugate is if you have like a plus square root of b, the conjugate is a minus square root of b. And the reason is because that's going to cancel out our square root. Okay, so on this one, I would multiply by 4 minus square root of 2 over 4 minus square root 2. Okay, so on the top, we're going to distribute. 6 times 4 is 24 minus 6 times the square root of 2 over. Now, the reason we multiply by a conjugate here is because of the plus and minus, it's going to cancel. So when you multiply a conjugate, you multiply the first 2. 4 times 4 is 16. And you multiply the second 2. Positive square root of 2 times negative square root of 2 is negative square root of 4. So if we simplify that a little, square root of 2 is square root of 4 is 2, which means on the bottom I'm going to have a 14. So then you say, well, can I simplify anything? If you can pull something out of all 3 of these, that means it can be simplified. So we can pull a 2 out of all 3. So if I pull a 2 out of everything, not the radical, then this would be my final answer. Okay, so let's try one more, number 12. Again, we're going to multiply by the conjugate. So I'm going to change that sign to a plus here. So on the top, we're going to distribute. Square root of 5 times square root of 2 is square root of 10 plus 3 times the square root of 5 over, again, when you multiply these, you just multiply the first 2. Square root of 2 times square root of 2 is 2. And negative 3 times positive 3 is negative 9. So we have on top square root of 10 plus 3 square root of 5 divided by negative 7. And I can't simplify that one at all, so we are just going to leave it like that.